one from start to finish with you all. We're going to do this one. You're going to get a little bit of practice. You're going to give each other feedback. Life is going to be good. So, the integral of sine squared 2 theta cosine 2 theta d theta. Yesterday, what I said in the world of integration by substitution, the uglier the integrand is, the more likely it is that substitution is going to be the way to go. So I want you to have just take a moment. If you look at this problem with fresh eyes, do you see the baby and the derivative of the baby? Baby and derivative of the baby. Baby and derivative of the baby. Oh, yeah. Thank you. For those of you that are struggling to see the baby, I want to offer up one little thing. Way back in pre-calc with Mr. Salhotra, he would always write sine squared of x. Textbooks always write sine squared of x. But when I say sine squared of x, what is that really? Adriana, what is that really?
It's sine of x.
It's sine of x squared. Usually for like the calculus kid brain, this makes things more obvious than this version. So if I just rewrite this problem and say, oh, it's not sine squared 2 theta, let me think of this as sine 2 theta squared times cosine 2 theta d theta. Is it easier to see the baby? We see the baby? Jose, where's the baby?
Oh, it's that sine 2.
Okay, we think that's the baby. I know if I'm choosing the right baby if I also see the derivative of the baby. If this baby is sine 2 theta, what's the derivative?
1/2.
Derivative. The derivative of sine is cosine. Do I have cosine of 2 theta times 2?
Times the baby.
So let's do the little side work over here. If u is sine 2 theta, what we did yesterday is we said let's find du d theta, which is the cosine of 2 theta, but don't stop there. Times 2 because we have to use the chain rule. If this is the baby, is this the derivative of the baby? It's not quite the derivative of the baby because our baby, the derivative of our baby is cosine 2 theta times 2, but the good news is I can get there. And what's the key to getting there?
Multiply by 1.
You want to be careful. If du d theta equals all this, the key is multiply this guy by what you need to get there, which is a half. So we get to a half du d theta equals cosine 2 theta times 2 times a half. Well, that's just 1, and we stop there. Your goal, though, you're going to know that you're doing this correctly if you can come over here and rewrite the entire integrand using only the letter u in du. So let's see, can I do that? Instead of sine 2 theta squared, u squared. Instead of cosine 2 theta, I'm going to put in this 1/2 du d theta times d theta. And at first, I'm not sure that I've made the right choice. But this should be the place where you start to see nice stuff happen. Like?
If you can cancel, then you know you're going to...
Okay, can I cancel?
Yeah, the d theta.
I can legally cancel the d theta in the denominator with the d theta in the numerator. This gets me closer to something that I can integrate. I like this. I feel good. So then your next move, Jennifer?
Oh, you take out the 1/2.
Why can I take out the 1/2? You're 100% right. Tell me why.
Because it's a constant.
That 1/2 is a constant. So 1/2 the integral of u squared du. Great. I think I know how to integrate this. Because you don't stop yet. I need to ask the question, what is the integral of u squared du? Integral of u squared du.
Plug in the function for you.
Don't plug the function in yet. The reason that we're doing this is to get something simple, something that you can see on, you recognize on sight. How many of you guys know the antiderivative of u squared du? One person? Two people? Three? Don't let the u confuse you. If I ask for the integral of x squared, everybody would tell me?
1/3
1/3 x cubed. So this guy here is 1/3 u cubed. So it's a half of a third, that was a u that got away from me, of u cubed plus c. I can clean this up and say, oh, well that's just 1/6 of u cubed plus c. And the mistake I want to make sure that we all avoid, because this would be really bad if we fell for it. Yeah, you can't stop here. You cannot stop and leave the, Jonathan, what do we need to do? Okay, you're gonna plug in me. I hope there's space. Okay, 1/6 u cubed, 1/6 sine 2 theta cubed plus Charlie. And I think that's the right answer. I could be wrong. It happens. If I want to know for sure that I did this right, I want to know for sure that this is the antiderivative. Jasmine, what's your advice? If you want to know for sure that that is actually the antiderivative, what would you do to make sure? You would find the derivative. And to find the derivative, you need a chain rule, and I'll tell you, it's going to get you back over here. Substitution is just a way to take this ugly, nasty integrand and make it look like better, at least for a little while. Kind of like prom. You rent a tuxedo, you look really good for a little while, you know. I don't know where that analogy came from. We'll have to edit that out. Edgar.
For like quizzes and tests, are we gonna have to show the check part?
You do not have to show the check part, but I think some of you, like if it's a multiple choice part of the test and you're like, gosh, I have no idea what to do, you might look at the answer choices and say, let me go find the derivative. These things work. Okay? I think some of you are going to get to the point where you're not even going to do the side work. The angels whisper to you. You see it and you're like, oh, sine squared. Yeah, Lucio is really good at this. He's like, oh, it's going to be like something to do with sine 2 theta cubed, and I'll kind of figure it out. But that's how his brain works. All right, so here's what we're going to do for the next 10 minutes. I want you guys to get some practice. Everybody needs a partner. You need one partner. So I need one of you maybe to come over here. And Ranbir, you're going to stay over there. Can I get one of you to come over here and work with a partner? Okay, figure out who your partner is. Raise your hand when you know that I would need. Choose your partner. One of you is partner A. One of you is partner B. Choose your partner. Identify who's A and who's B. From here, you're going to need A for sure, and then.
Yeah, I better look at that. Dang it.
All right, touch your finger to your nose if you are partner A. Partner A, where's partner A? Touch your finger to your nose. Finger to your nose. If you are partner A. Okay, partner A, you are going to solve this problem over here. Only going to solve this problem over here. Partner B, you're going to solve this problem over here. When you are ready, when you both think you're finished, switch, look over each person's work, give them a little feedback, and then move on to round 2. You've got 12 minutes. done. Switch partner, switch papers with your partner.
Subtraction.
Yeah.
Can you explain to me where you got the various options for U over D clear? How it equals times 2 beta times 2 is 2, like you just take the derivative.
Right, so do you need theta? Take the derivative.
So for this one, like, all of the to this power would be
The u would just be the x1. It's just the x1. Here you go, Jennifer. Jonathan.
So then would you say
Daisy, here, handle your stuff. Okay. Partner A. What's the baby?
3x squared
I
minus
didn't know.
5.
Partner A is 3x squared minus 5. And you should be thinking, I know I chose the right baby because the derivative of the baby is 6x, right?
Yeah.
Can I get x to show up?
Yeah.
Using multiplication or division? Sure. Partner B, where's the baby?
Bottom.
Probably the bottom, but the way you know for sure, 2t cubed minus 3t squared plus 2, that's the baby. If I take the derivative of the baby, that's 6t squared minus 6t. Can I get this t squared minus t to show up? Sure, more multiplication. Finish it off. Trade papers when you're ready so that you get feedback from your partner.
I think I did it.
Hold on, let me see yours.
I got 112 times 2t.
If you don't do well on the quiz on Monday, you're going to be able to blame your partner because they didn't give you good feedback.
I thought it was your turn all the time until I can do
So it's x to power
t squared minus 3.
What did you use so you could get the
so
derivative?
would be like simplified like
You have to get
Oh, wait.
I don't want 6 e to 3x squared
So then you have to.
Yeah. I got that too.
You forgot to put this thing.
I mean, I
Look
did.
at this.
That's
T squared. Also, it's 1 over 6.
Find the derivative of it.
that's you. No, that's you.
Find the derivative.
T squared minus T.
And you find the derivative. So like, right now you can subtract.
You gotta want to do
Is that it?
No, 1 6 times.
Is that it?
And you're trying to get to x, yeah, so you have to do
Yeah, we got it.
Oh,
is that right?
du, whatever.
So,
6x, right?
And then
okay, so this is the u, that's the
the u,
derivative.
this is u.
So if you multiply by 1 6, you get the numerator. So you've got 1 6, now why u to the negative 2? That's the part I don't agree with.
Times 1 6.
So the important piece that you're missing is when I rewrite the integral, the numerator is just 1 6 du dt. The denominator is just u, and I multiply by dt. The dt's cancel out. The 1 6 is a constant, I can pull that
It's
out.
just the derivative, yeah. Just that.
So you've got 1 6 integral of 1 over u dt.
You get this equation.
This has to be text for log in the app. So it's
Whatever it
not-
is times CX. And then after that, remember, you know you're doing right if you cancel all the DXs.
Nice. And are you guys partners?
Yeah. Me and
They
Jose.
have the same,
Yeah.
the same
DU,
problems.
whatever.
Okay.
And then after that,
So I'll be partners.
you find the
Grade paper,
you find the answer.
feedback, when you're ready.
Yeah, you find the answer. You want?
The bottom.
I just know you get here.
Everything's great.
That's what I do first. I do it out. I mean, yeah. I mean,
And then this that gives you.
when you write it.
Because that's what I do.
Right, you check the foldable, like when I asked that, what's the integral of
I know
t?
that I have to multiply times.
The answer is e to the x. Not e to the x times stuff, just e to the x. When you and your partner are ready, my answers are up there if you want to check, but move on to round 2. Found the derivatives. Now the question is, can you get numerator?
Oh, you just simplified it by putting.
I did the same thing you did. I put X and then you represent it, which is the baby. And then I'm multiplying times 1/6 y dx
How did you set up the
times
note?
dx. And then I know I'm going to write a right equal dx.
Like once you have,
No, we're not there yet. Just like right into the final answer.
Right, you're replacing the t squared minus t with this 1/6 du dt. That's the whole idea with substitution. We want to get all the original variable out, put the new variable in.
Oh no, I didn't write
you did it in your head.
Yes, 206, 16.
I can't do things in my head.
So it's 160. So 160 dt.
E3x.
And that looks like one of the other.
Yeah.
Oh, okay, yeah.
Right?
Yeah.
So t is at the bottom. The bottom slide there.
No, you're canceling out.
You get 6 times 6. Oh, 1/6. You just get this. This is basically your final answer. But you have to you back. That's it. And you factor out the 1/6.
What's the integral? What's the
It's the
antiderivative?
constant.
Right?
Or when you get here, you don't take the x, right? You plug in the x back. That's the
Right. A lot of times folks get hung up on the d, where did it go?
Is that sweet?
What's the antiderivative?
But that's a low.
natural law. Oh yeah, you found the derivative of it. The antiderivative of that is natural law.
Naturally, it's like bitter. So it's just
After the dx is there to tell you what is your variable.
Water.
Once
That was just water.
find the antiderivative,
That was like.
no, there's little.
and you never worry about it over here, but now substitution, wait, what's going on? Okay,
I don't think it'll work.
so you guys
I think it does work. I think about it. I feel like if you think it does, yeah. Over you, it's a minute. Yeah, I think it's. You said. Yeah.
shoot side data minus 1.
Did you finish? Mango?
I'm calling data.
No, you're the one who told me.
Don't worry about the shooting.
Wait, one over you.
No, it isn't.
It's like
Because you
basically.
can't
Friends, just figure how we do.
But there are words. There's words.
how I went from here to here or here to here.
To read
So two things happened. I took the 1/6 out as a
and
constant.
it's less words actually.
And then what I was left with was the integral of
It's just that,
1/6
like whatever they
e to
think
the
and
u
whatever they
du.
say.
What's the antiderivative of e to the u?
I know.
Just e to the u. I think what starts happening in the brains with the calculus students right now, you start paying attention to d differently. You put more emphasis on the du than you did before.
It's because you have basic knowledge. That's why sometimes I will have to go back to some episodes just to hear the words.
Don't think about it. What's the answer? What's the full answer? E to the x plus c, because the question is what function has this as its derivative? Oh, e to the x plus c. You're not getting hung up on the dx over here, right? You just know, oh, it's e to the x. Don't get hung up on the d here. What function has 1/6 e to the u as its derivative? 1/6 e to the u. Okay?
This part, you know when we find the derivative?
Yeah.
I thought it was like times 6. Because it was like 6x.
But here's the thing, du dx is 6x.
Oh, it ended up.
I have just one. So how do I turn
Get out
this
at, like,
into just 1x? You multiply by 1/6. Oh, you do.
Get out. And like this is
So excited. So excited. It is time for the next evolutionary leap. I have no doubt some of you are 100% ready for this. And others might be like, Coach, don't make me do this. Have faith. It's going to be okay. Monday is going to be a full-on practice day. Stickers raining down from the sky on everyone in class. It's going to rain stickers. So here comes the next evolutionary push for us. I want to do definite integrals. We've worked with definite integrals already. You guys know exactly what the process is for evaluating a definite integral. Tell your neighbor, what do you do? How do you evaluate a definite integral? What do you do? Keep it basic. What are your moves?
Evaluate it from B value
Alright, let's pull it together in 5, 4, 3, 2, and 1. I heard from at least 4 different groups. What you're going to do, you're going to find the antiderivative. Once you found the antiderivative, what are you going to do? You're going to plug in the endpoints. Done. Find the antiderivative, plug in the endpoints. Done. I even heard one group, they thought they were being snarky about this. How are they going to find the definite integral? They said, I'm going to plug it into my calculator. Does that work? Yes! If it is the calculator active portion of the test, Jennifer, and you have access to a calculator and it's a definite integral, please type it into your calculator and be done. But this one, I want us to do carefully. That Jennifer, not that Jennifer. Not purple Jennifer. Okay. I want to find the definite integral from 0 to 1 of x over x squared plus 1 cubed with respect to x. I want to do the first one, just start from finish. There are some new moves coming your way. I got moves. Okay? I heard some folks already say this has to be substitution. How many of you guys see it as a substitution problem? You're convinced. Adriana sees it, Noemi sees it, Edgar sees it. One, why are you convinced substitution?
Because when you take the derivative of x squared plus 1, you get x.
Okay. What? So it sounds like you're identifying the baby. That's one reason to think substitution, but it's not just baby. It's that you found the baby and... Jonathan? You need what? Do we have the derivative of the baby? We absolutely do. The derivative of the baby, du dx, is 2x. Now, I have been experimenting with your brains for the last day and a half. I had a new way to show you integration by substitution. It's not what I've done with the 7th period class. here's what the 7th period class and I are doing. Once they find the derivative, if this works for you, go with it. What they're doing is they're saying, I'm going to automatically multiply both sides by dx to get du equals 2x dx. Is that legal?
Yeah.
As long as I do it to both sides. Here's the advantage. You now have the dx in a good place. Right, you're multiplying by the dx. Look at your integrand. You've got x times dx. If only I knew of a way to rewrite this as x dx. Gosh, if only I knew a way to get x dx to show up. I'm going to multiply by a half or divide by 2. So a half du is equal to x dx. And here's what we do in 7th period. We've just been saying, okay, let's go and rewrite it. Rather than saying x dx, that's my 1/2 du. Rather than saying x squared plus 1, the whole thing cubed, I'm just going to call it u cubed. We don't have to worry about the canceling of the dx and the dx. They're taking care of that in this step over here. If that works for you, great. Okay? I think this maybe is good, but here's where I want to be really careful. This integral over here is incomplete. In the world of definite integrals, if you're going to do substitution, you don't just change the integrand, you got to change your limits as well. You have to change the limits. Everything up here, this was like x equals 0 and x equals 1. My integrand was in terms of x. My variable is in terms of x. All these guys change to u, the limits change to u. Everything changes over to you. Okay? Well, let's see. If x is equal to 0, what's the u version? If x is equal to 0,
1.
u is
1.
Abraham, why 1?
Because you put it back into you.
Right? We know that x is equal to x squared plus 1. So if x equals 0, then u is 0 squared plus 1. So my lower limit is 1. My upper limit says x equals 1. Well, in terms of u, that's 1 squared plus 1, which is 2. This is the right way to do integration by substitution with a definite integral. Change the integrand and change the limits of integration. One of the things the College Board has been doing over the last couple of years, sometimes they just say, if you rewrite the definite integral, what does it look like? All you have to do is the rewrite. Sometimes that's what they ask you to do. But let's finish this off. Let's see. I want to evaluate this definite integral. That half's a constant, no surprise. Factor it out. I've got 1 over u cubed du. I'm integrating from 1 to 2. Okay. Now I need to know what's the antiderivative of 1 over u cubed. And slow the roll. Someone in this room is having a bad, inappropriate thought. Somebody is wanting to say, oh, 1 over u cubed, I know how to find the antiderivative. Somebody wants to say natural log of the absolute value of u cubed. We are not going to do that. That would only work if this was 1 over u. The right thing to do
Rewrite it.
is you got to rewrite this. You're going to say, oh, this is u to the negative 3rd du with a little half in front from 1 to 2. Antiderivative of u to the negative 3, add 1 to the power. Less.
Thank you.
Divide by the new power. Don't forget about the 1/2 that's out in front there. I think I was a little messy there. Antiderivative of u to the negative 3, add 1 to the power, divide by the new power. Don't forget about that half you're multiplying by. And now evaluate from 1 to 2. Half times negative a half is negative a 4. Instead of u to the negative 2, I'm going to call that 1 over u squared. I've got to evaluate from 1 to 2. Plug in the 2, negative 1 over 4 times 1 over 2 squared, minus negative 1 over 4 times 1 over 1 squared. Don't start freaking out, it's just 6th grade math. 2 squared is 4, I've got a 4th times negative a 4th is negative 1 over 16. 1 squared is 1 times a fourth is still 1/4 plus a fourth. Negative 1/16 plus 1/4, 3/16. Just get caught up with your notes and then I'll take any and all questions.
That's another way?
That's what?
That's the other way?
Well, this is the first time we're evaluating a definite interval. The only other way was this multiplying both sides by the dx so that you get rid of it right away. The only really new piece is that when you do your integration by substitution, you don't just work on the integrand, you have to go for those limits as well. You have to change the limits. So, here's what I want you guys to try. I think most of you guys are ready to try partner practice number 1. Just take like 4 minutes, show me what you can do. Partner practice number 1. And then I'll really blow your mind.
Oh, more.
Yeah. Partner practice number 1.
Oh, that's
Take the box.
no, because I didn't see the 316 on there.
Give me one of those.
1 over 16 is right.
Call. Okay, and where are the friends that have questions about all the stuff that just happened? I know you're out there somewhere. Where did I lose you? Here? Okay, so identifying the baby's okay? Finding the derivative of the baby? And this new, let's multiply by the dx to get the dx over here, okay? So is the question, why are we multiplying by a half?
I'm not there yet. We already.
You're okay with why we're multiplying? Okay, so we multiply by the half. Why are we multiplying by the half? I want to get rid of the 2, and why do I want to get rid of the 2?
Oh, wait.
Back to the integrand. Look at your target. You're trying to rewrite all this stuff. What I have is x dx, so if I multiply both sides by a half, I get 1x dx to show up. Now all this stuff over here, a lot just changed on it. In the original integral, I had x squared plus 1, the whole thing cubed, that becomes u cubed. X dx becomes 1/2 u. My limits of integration were originally x equals 0 and x equals 1. Now, because we know that u equals x squared plus 1, rather than saying x equals 0, u is 0 squared plus 1. Rather than x equals 1, u is 1 squared plus 1, so it's 2.
Not the same thing.
Are we okay getting here? Daisy, are we okay?
Where, can you repeat the 1/2 one again?
Or
The reason that we're multiplying the derivative of the baby by a half is to get the x dx to show up. And so if I multiply by a half, that's how the x dx is going to show up. Jennifer, were you okay once we got here, or was there more stuff after here? Okay. So how did I go from here to here? What did I do?
You plug in 4 into this.
So I'm integrating from 1 to 2, 1/2 to u over u cubed. That half is now in front of the integral. Because it's a constant. And it's okay for me to take the half out in front. I need to find the antiderivative of 1 over u cubed du. I rewrote 1 over u cubed as u to the -3rd, which is legal. And now I can use my power rule that says add 1 to the power, divide by the new power. So u to the -2 divided by -2 times -1/2.
Okay.
I think.
No, that's when you're solving for it.
Right. Add 1 to the power. I always focus on the power first. Add 1 to the power, then divide by
I mean,
the new
regardless, you have to change it.
1/2 times -1/2 gave me this -1/4. Rather than calling it u to the -2, we're going to call it 1/u squared.
I don't know where to go from here.
Yeah.
Because you can't find the square root. Yes, you can. So it's just square root of 25. 5 for this right here.
No, u isn't square rooted. U itself is just under the square root.
What's 1/2? Yeah, because the 1/2 everything get -3, right? Because if you multiply
You're not square rooting it. You're not square rooting it.
I'm not looking for it.
Because this is just u.
Yeah, because of the
Yes.
When do you stop writing
so it's 2 and then 2 is
over, okay, the limits of integration?
Yep.
When do you stop?
When you find the antiderivative. Right, when I ask the question, like, what's the antiderivative of u to the -1?
This person
The
has
-2 divided by -2. It is at that point, once you have found the antiderivative, that you don't write anything.
I'm asking like, when do you get
I was doing it right now because I wanted to be. You all make a little bit of
But it was like athletic.
What I thought as is
But you have to change
All right. Alrighty, friends.
Yeah, I thought you
We've only got about 7 minutes left. Monday is a full-on practice day. Let me tell you what tonight's homework is.
Yeah, that's what I said.
Okay, tonight's homework is to do partner practice and support questions 1 through 4. And do the first 4 where it says tonight's homework. That's different than what I had planned. So it's the first 4 for partner practice and support. And then the top 4 over here. In total, 8 problems. On Monday, you're going to walk in, you're going to check it. I want to do 1 just to blow the minds of those folks that are like, I've got this under control. I know who you are. Okay, here we go. Why not? I want to keep pushing.
Comfortable.
Exhibit B. Hello, new friends. We'll talk in a little bit. All right. So, problem number 2. Integral from 0 to pi over 4, tangent of theta d theta. My question to you all first is, what has tangent theta as its derivative? Don't tell me, tell your neighbor. So funny, I just heard 8 different people say secant squared. And all those folks are wrong. Why? Why? Let's get some hands on this. Giselle, why is that wrong?
Because the antiderivative of secant squared is tangent.
Okay,
That makes sense.
so all the folks that just said this are getting themselves confused. We do not know the antiderivative of tangent theta. What do we know? We know that the derivative of tangent theta is secant squared theta. You're answering the wrong question. So, I want to look at question number 2 with some fresh eyes. We're going to have to go fast here. Anybody know any clever ways, clever things you can do to tangent that maybe will make things clearer? Mariah, what do you know about tangent?
It's sine over cosine.
Okay, is it legal to rewrite tangent as sine over cosine?
Yeah.
Yes. Now, I bet you see it. You've rewritten tangent as sine over cosine, which is legal. Who sees the next move? 1 person? 2 people? 3? Maybe 4? Jose, what's the next move?
Oh, never mind.
Oh, you big tease. No, Amy, what do you think the next move is? Okay, if you think the baby is the cosine of theta, that sounds to me like, Noemi, you're thinking like integration by substitution is the way to go. Well, is it?
Not necessarily.
Not necessarily. You need to know that you have not just the baby, but the derivative of the baby. Do we have the derivative of the baby?
Yes.
Yes. Ah. So, oh my God, somebody said sine.
No,
Derivative. The derivative of cosine theta is negative sine theta. For those of you that like this new idea of multiply by the d theta, great. du, I know. du equals negative sine theta d theta. Okay, I've got, this is my u. That's good. But my integral involves sine theta d theta. I need to get this guy to be sine theta d theta. Don't overthink it. The legal thing that you could do here, you could say divide by -1, you could say multiply by -1, doesn't matter to me. If I multiply both sides by -1, then the negative of du is equal to positive sine theta d theta. Oh my God, look at this new integral. Look at this new integral. I'm not going to write cosine theta anymore. I'm going to write u. I'm not going to write sine theta d theta anymore. I have a better way to write that.
Negative du.
It's -1 du. Don't make the rookie mistake. If you're changing your integral over in terms of u, everything gets changed. All the things get changed, meaning your limits of integration. Okay, so you're going to do a little bit of side work. You're going to say, okay, originally theta was equal to 0. U is the cosine of that, so cosine of 0 is 1. Theta was pi over 4. U is cosine pi over 4. And cosine pi over 4 is the square root of 2 over 2. So my new limits are 1 and square root of 2 over 2. And we've only got 2 minutes left, but I promise that's going to be enough. We are on the threshold of greatness. All I need to know is what's the antiderivative of -1 over u with respect to u. Close.
Negative
Negative natural log.
u.
So this is negative natural log of the absolute value of u, and we evaluate from 1 to the square root of 2 over 2. Looks good, almost done, not quite done. David, why are we not done?
Oh.
Well done. You've still got to evaluate at those limits. So we're going to say negative natural log square root of 2 over 2 minus negative natural log absolute value of 1. Gosh, I love that answer. It could go a little bit better if anybody sees it.
Oh, plus negative natural log.
Okay. Right, this double negative, who's ever going to write that in calculus class? Never. But the other thing that you guys are likely to forget, Jasmine sees it, Nora sees it, stop saying factor. Jasmine? Natural log of 1 is 0. You either know it or you're taking advantage of the fact that it's up there in the poster and you're sitting super close to the poster. Either way, it's good. Negative natural log absolute value square root of 2 over 2. I will see you guys later. Be good.